starting off with where we are with this Jeep, what I want to show first is the cam and crank signals again, where we measured at the computer. And I want to, I think, just take 2 seconds to point out how I find wire pins at a computer. If you guys look, we go by sequencing, and what we did is we looked at the crank color, which is gray black, and then we look at the one next to it, which was tan red and then light blue red. We did that for the crank and the cam, tan yellow, orange, and gray black. We look for that sequencing. Let me show you that real quick on the camera. Just so you can see where I'm back probing this connector. It's going to be hard to get in there without pulling these back out and showing you the sequences, but that's what we did to locate the exact cam and crank signals on this computer connector. And of course the key is off right now, and we'll plug that back in and connect our leads right to there. Why did we choose that location? We pretty much got beat up real bad trying to go underneath and locate the cam and crank signals directly at the sensors. We can't even see the crank sensor. It is buried. It says it's above the starter on the diagram, right?
It's a lie.
Yeah, and I can see the harness. I cannot get to it at all. Can't get my hands in there. This thing is stuffed in here. I have absolutely zero access to the crank sensor. Rather unfortunate. What color was my crank? Was gray black, right guys? If you look on my desktop, you'll see I think the crank was gray black and the cam is tan yellow. Yeah. All right, we'll crank this thing over here. The hard part about this at times is knowing whether or not you have a good connection. Let's say we have no signal. It could be a bad connection, or it could be that we have no signal. You know, these are things we need to always be thinking about. So I should have this set up properly. We're on a 5 second screen, 10-volt scales. You know, we haven't done really a lot of scope stuff yet, but that's okay. We'll get to that. And can I get one of you guys to crank that for me? You know what? Just turn the key on first. Okay. And my cam is the green. My crank is the yellow. We're reading 5.2 volts on the cam and 0.13 on the crank. Go ahead and crank that over. Okay. So here's what I know now. I mean, it's okay that we did the theory that we did on this. We weren't making connection with the crank sensor yesterday. I'm very, very excited about that. What we should have done is filmed all of the cussing going on as we tried to access the crank sensor. Because remember, we wanted to go to the crank sensor, do some unplug it tests, see what the voltage does. And the nice thing now is I have a crank signal, and I am very excited about that. Can you guys understand why? Because guys, listen, on this Jeep, to be honest, this vehicle, I have never seen one this bad, ever. That I couldn't get to the crank sensor, couldn't get to the wiring to the crank sensor. If this ended up, guys, this is one, if it ended up just missing the crank signal, this will be one you'd throw apart at it. You do your wiring checks at the computer, make sure everything looks good. 5-volt pull-down design. We could do some tests as far as pulling the pin out. Remember, I had that discussion with you guys about figuring out circuit design. We can do stuff like that, but that'd be it. There's nothing else you can do. Anyway, I'm excited that we have a crank signal. Did you guys see it? All right. One of the things that we did in that capture, it's probably gone now. Let's see if I was probably talking too much. Oh, okay, it's still there. So right here is where we cranked it, and let's zoom in on that a little bit. What we did as far as our scope setup goes is we have too much time on the screen. We can't see the square wave. Some of you might be thinking, well, wait, that's not a square wave. What is that? How do you know that's the crank sensor signal? I've used scopes for a long time, and I know that we gathered too much time, and we can't see the detail in that. So what I need to do to fix that, it's real easy, just drop my time base and redo the capture. So what I'll do is exactly that, hit stop on the picture, and I will change it from 5 seconds to, I don't know, let's go 200 milliseconds, and go ahead and crank that again. Keep cranking, keep cranking, keep cranking, keep cranking. Okay, good. So I gathered that data, and now what I'm going to do is zoom out on that. And this is kind of what it looked like a second ago, right? We saw all that crap in there. But now I have the ability to go ahead and zoom in on that recording, and we can really see that our crank sensor signal. Yeah. And now we can see some detail in that crank sensor signal too. You see we have some fatter ones and some skinny ones, it looks like. Now, do we see repetition? So one of the things that I look for too in acquiring signals would be repetition. Repetition meaning it looks like I see a fat one, 3 skinny ones, a fat one, 3 skinny ones. Is that what you guys are seeing too? So I see a specific sequence in here. That's helpful. And but I'm not going to overanalyze that signal right now and say, okay, the fat one does this and the skinny ones do this. That's irrelevant to me right now. What's important right now is I have a crank signal. Now, what threw us off yesterday, if you guys remember, is we were losing scan data during a crank. Let's see if that's happening again. I'm going to go to my Home tab, go back to my scanner, well, we could read the codes too before we... Is my key on right now, Derek? I haven't got your name right.
Dustin's nice now.
So I have a no cam, but didn't we have a no crank too yesterday? Yeah. So we had a crank sensor code yesterday, we had a cam sensor code, and then we had a leak detection pump code for the evap system. I'm not seeing those now. We didn't clear the fault codes. Let's see what the one-trip faults are. Okay, so the only code we have in memory is the cam. We can still, this will still be a good review of where we are. The nice thing about this is the cam sensor is actually accessible. It still sucks to get to too, but at least it's something I can unplug and show you the tests involved.
Weren't you talking about you shaking the harness like you were, that it could fix the problem?
Yes, that was a concern too, and we should have maybe been filming for that part, but yes, when we're dealing with no start conditions or intermittence, when you start moving harnesses around, you can fix a problem, and that's a good point. I almost called you Dustin. Brandon, if we...
You're consistent, I'll give you that.
I guess I had a Dustin in class that he reminds me of Dustin. I'm trying to get rid of it. I'm having a difficult time.
I'm not.
Remember, it's Brandon with an I.
I got it. I got it. Maybe that's why I'm all screwed up.
Just think of big.
Probably not. Probably still Dustin.
He's still Dustin.
All right, anyway, what was I saying? I lost my train of thought. What was I just talking about?
We were talking to Dustin.
Dustin and you
We were shaking.
Shaking the harness, recreating a fault. That's a good question. You guys understand Brandon's question is it a potential that we fix this crank sensor fault and now we have a crank sensor signal? That's possible, but here's the thing, it's still a no start, so I don't think so. We had a no start before, we have a no start after. And guys, when I checked your connections at the computer, that crank sensor pin was not in all the way. I don't believe we ever read the crank sensor signal yesterday. The 0.9 of a volt that I've been talking about the last couple of segments was just voltage floating around in the air. Some people call it ghost voltage, right? You're picking up, there's AC voltage floating through this whole entire room. If I disconnect my scope, I can show it to you, and I can graph the frequency and show you it's a 60 hertz signal that's just floating on the tip of my lead, not connected to anything. So we have that happen. Okay, there's something else here that I just noticed. Something changed. You see my ignition cycles are at 0? You see that 1, 2, and 3 are at 0? Chrysler has a method where they keep track of fault codes that are in memory. And when you have a 0 ignition cycle and a trouble code, that means it just happened. These were in the hundreds yesterday. Something changed. You know what changed? We disconnected the computer when we plugged in our our test leads and we wiped out the computer memory. So there's 2 times you'll see zeros on your ignition cycles, and that would be someone just wiped out the computer memory, cleared the fault codes, or you have 3 different hard faults. 3 different codes, 3 different hard faults. We wiped out the memory on this, which was actually helpful in a way, because you wipe out the memory, you crank the engine over again, and the only one that comes back is the cam sensor fault. Makes it a little bit easier for direction, doesn't it?
Yeah.
We have a cam sensor fault. All right, let's see if we're losing our info on a crank. Go ahead and crank that again. We were losing this information. Keep cranking. All right. We're not losing our data now, so it changed. We were losing our information yesterday during a crank. Didn't like that either. I'm not sure why. Question, Scott.
When you look at the crank, you got a count up there, but the cam there's 0.
Good. All right, so these would be data PIDs. So think about our switch inputs we talked about. Move the switch, look for a data PID change. Remember that discussion? And we said high, low, on, off, right? Well, is a crank count a data PID that changes? Crank it again, our battery's almost dead. Let's watch that crank count. So we're looking right here. Look at this guy right. Oh, hold on. Look at this guy right here. Keep cranking. Keep cranking. Okay, cool. So it looks like it holds the last number that it saw too, as you can see. But that alone says what about the crank sensor signal? It's there. You don't need to scope test it. So that's pretty cool. And notice that our cam count stayed at 0. So now what do? This is where we go to the sensor. We figure out its design. Is it pull up, pull down? We know this going into it. It's Chrysler. You know the splice we mentioned with the TCM and all of that? Doesn't matter anymore because the crank is there. And the crank's the only one that spliced. The cam did not. So we're just dealing with one simple circuit. Where do we start? Go to the Home tab, back to the scope, and where we start is looking at this data maybe a little bit more zoomed out. And what we see here, guys, is we see a fixed high voltage on the camshaft sensor signal. Where am I measuring though? I am measuring at what? The computer, not the sensor. Okay? So let's go back to here for 1 second because we have to do this again. I'm measuring at this location. Cam sensor signal, I have a T-pin here and I'm connected to my scope. I am reading a flat line 5 volts. We know the sensor circuit design now. Our circuit design is this goes to a transistor inside of the Hall effect. Right? And what we say yesterday about that transistor, it needs a power and a ground to work. If I'm missing a feed or a ground on the cam sensor, could I have this condition, a fixed 5 volt line? Answer is yes. We did some other checks though. We checked the map. We checked the map ground. They were good. What else is good? The crank is good. Crank is working. Doesn't that suggest our powers and grounds are good because those are shared circuits?
Yeah.
Yes, but that doesn't mean we can't have a break in the harness right to the cam sensor, so I have to go to the cam sensor and do this manually underneath. I can't just go and rely on those other tests. There's another issue here, and that could be that my signal wire is open between the computer here and the sensor here. What would confirm that? Do I need to use an ohm meter? No. All I need to do is check my voltage at the sensor. If I read 5 at the sensor and 5 at the computer, how is this wire? So I have 3 checks to do. Power, ground, signal at the sensor. Make sense?
Yeah.
And we'll be able to make a call. Looks like a bad cam sensor. This particular vehicle needs cam and crank to start. Here's the unfortunate part is we're filming live. If I touch that cam sensor connector, I may fix the problem. So as we go here, if I'm back probing this and the car starts, that in itself is telling you need a cam sensor. Some people say, well, you move the harness, so that's probably a harness problem. No, what you need to understand is when you move a connector, you have your cam sensor here, you have these male pins that come out, and then your connector would be female pins and wires, right? When you move the connector, what people don't understand is you are actually stressing the male pins in the connector of the sensor itself. When you move a sensor connector and it now starts to work, 9.9 times out of 10, it's not the connector that's the problem. It's you stressing the male pins with the female pins of the connector. Make sense? So I'm just a warning here so we don't have a ruined video. It's really not going to be ruined if this car starts. I think we learned a lot about this system. I'm going to go underneath, check power, ground, signal, and then those look good. I'm going to do the bypass test and show you on the scan tool that we can make that cam data PID count change with the bypass test. All right, maybe we'll try with your LED test light too to see if it works. I don't think it will. Be curious to plug that in here too and see if that works. I'm underneath the truck, the Jeep, and there's my cam sensor connector right there. You see it?
Yeah.
See my wire colors? I got orange.
Orange, black, and yellow.
That's actually black with a light blue and then a tan yellow. So tan yellow is my signal wire to the right. You see it? I'm going to back probe that one first. Not sure I'll be able to do both of this at the same time, but I'll try.
Hey, did you lose that connector?
What? I'm sorry. I'll get it back to you in a second. Oh man. Remember yesterday I couldn't back probe the map sensor because I said it was baked. Like the weather pack connectors were like super hard. Something else to point out here, guys, because we had coolant on the ground as this has been sitting in my room. Here's my thermostat housing, and you see it's all wet. It's leaking coolant there. This engine was overheated, and that will bake these connectors. And the bad part right now is I cannot back probe this because of how brittle the weather pack seals are. So I don't really have a choice but to use a hook tool and do it that way. So I can't use my little pin here. I need to grab my hook tool again. It's on the map sensor up there. Can you take that off? You have to unscrew it and then unhook it. And that's the one I'm going to have to use.
Now, because they're cooked, are we going to be able to replace the sensor?
Yeah, I'll still be able to unplug it. It's just I can't back probe the connector like I like to, that's all. Three checks, guys. Okay? Sorry. Whatever you said, my other camera probably picked it up.
Oh, it picked it up all right.
What did you say?
That's not his arm.
Shut up and get out of his life.
Okay, guys, listen. Guys, listen. I'm going after the feed wire first. Okay. Using a jumper wire to my connector because my test leads are not long enough.
You're on the yellow lead.
I'm on the orange. I'm on the orange, which is my reference wire. Okay, and guys, because that completely sucked, I'm not taking that camera back under there with me. You guys saw the connector. All I'm going to do is go down the line. We'll keep you guys focused on the lab scope. So I'll get you back on that screen. Okay. And all we're going to do is unfreeze that. And we will look at our...
Which color is the one you're on underneath now?
The green, guys, the green trace is my cam signal, okay? What do we have on the green trace? You guys see it?
Yeah.
Key is on. So how's my supply voltage to my cam sensor?
Good.
It's good. If you want to crank it, you can. We can get another shot of it cranking. You don't have to freeze it. Go ahead. Okay. How's my supply?
Good.
It's good. Stayed at 5, right?
Yeah.
Nothing wrong with that. Let's go to the sensor ground now. Key's still on, right?
Yes.
Okay. I'm going to move this over to the sensor ground. Sensor ground. Coming up next. See my voltage right now, guys, at 0.6? You guys see it?
Yeah.
The key is on.
Yep.
And what we said about sensor grounds is it should be 100 millivolts or less. Let me give you a little tip here. I am underneath with a jumper wire. Kind of tough to show all of this, but here's my lead that I'm connecting to it. If I shake this lead, you'll see, well, we're pretty steady at 0.6, huh? It's not really moving a whole lot. I don't know if I shake it more, if I can generate more voltage. Watch when I plug it into the sensor circuit, which is with my jumper wire. Did you see it drop?
Yeah.
So that's a good indication that I'm in the circuit, number 1, and number 2, that is a good ground. Make sense?
Yeah.
So I'm at 0.01, that's 10 millivolts. Now, if we crank this, it's going to jump up, but we don't do cranking tests because of block voltage, block grounds. I'm good with that. If you want to do it, go ahead, crank it, watch the sensor ground. Okay, so it's 300 millivolts average. Guys, you can't use that number because you're throwing hundreds of amps at the block. You're raising block ground voltage. That will raise all your sensor ground voltages. There may be a slight grounding issue on this block, and if you look at the battery, you'll understand that this is pretty bad. Would it be wise to clean up these terminals? And you know, we could, but not our concern, guys, okay? Last one is my signal wire at the sensor, and I'll just keep you again focused. You guys focus up there. I'm just going to move this over to my signal wire. All right, signal wire. What should this be?
5 volts.
Remember what we were at the computer, guys? When I was tapped in, so keep in mind, let me just get you a shot down at my connector. I am underneath the car right now. I'm at the sensor. Where was I before? I was over there at the computer. So here's my question to you guys. Of my variables, of my options for faults, do I have an open in my signal wire? Here. I'm measuring 5 volt. I have 5 in this location. I have 5 here. My signal wire is what? It's good. And we know it's a 5 volt pull down, so we know the computer's good, we know the wiring's good, we know the feed is good, we know the ground is good. Are we done? We are. We're done. It needs a cam sensor. Anything else we can do to make us feel better about it?
Drink a beer.
Drink a beer might make you feel better about it. The bypass test. Do we have to do the bypass test? Is the bypass test critical at this stage? No. But can I do it to show it to you to make us feel better about making the call? Hey, we can change this cam sensor. We're going to be okay.
A beer does the same thing.
There's only one other thing though, guys, and that would be mechanical movement. Is it possible that, you know, the timing chain's broken and the cam's not turning and that we don't need a cam sensor? So mechanical movement would be important. There's certain things that says it's probably not that. By the way it cranks, it sounds normal. It doesn't sound like it has a broken chain. But that's as simple as taking the sensor out and looking up inside and seeing if there's movement of the cam. We're probably not going to do that for this. You know, we're staying focused on electrical. I'm going to grab my test light, do the bypass test. I'm going to start with an incandescent test light. And I'll keep you guys focused on the... I'll actually do both for this one. I'm just going to take the green lead off of the top right here. I'm going to take this green lead off the top. Why? Where's the green lead going? To my cam sensor signal. You can see on the scope it shows 5. No, you know what? I'm not going to do it that way. I changed my mind because I want you guys to see that signal get pulled down to ground with the test light. I'll do it back underneath where I was. I'll have that screen up there so you guys can watch it. I'll just come down this way and I'll do it down here. Test lights go into what? Battery positive or battery ground for a pull down bypass test?
Battery positive.
I want to pull it down. I don't want to give it voltage. I want to go to ground, right? Test light to ground. I confirm the test light works.
We lost signal.
No. Okay.
We just lost block.
It's still rolling? We good?
Yeah.
Okay. Watch it. Let me get this light out of here. I'm going to take this signal on and off. Did it just drop? I can hear the injectors firing.
I don't see it dropping. Oh, there we go.
Yeah, it is.
All right, so and the engine just like tried to start.
Yeah, it did.
This is pretty delayed here. Let me change the time base. What is that? That was weird. I don't know why that would have triggered the crank. Oh, you know what? It triggered the crank. It actually moved the crankshaft when I did this. Let me go to a 1 second time base, let you guys see that.
So while you're doing that, if Derek cranked the key, it would start?
It might, but hang on a second. Hang on. Guys, you see it? Am I pulling it to ground?
Yeah.
Am I making a signal? Did you see the crank just kick right there?
I heard it too.
Yeah.
Yeah.
Is the computer trying to start this vehicle now with this cam sensor? It is. It shows you really how much authority the cam sensor has on this vehicle over the crank, which is actually surprising to me. Here's what I want to show you though. Let's get a voltage level. See the min-max for the min-max for the cam? I'm reading 0.3 and 0.5. Let's refresh that. And you see the min-max changed? We're at 5 and 5. Can you see the min-max on the green trace?
Yeah.
Let's see what the incandescent light pulls it down to. What do we pull down to? What's my live number? 0.68, 0.69, 0.7. Let's see what the LED one does. Can I use the LED light to trigger this circuit? Is the question here now. By the way, that negative terminal is loose. I just moved it. Incandescent light to the same location. My incandescent light lights. And how much voltage do we pull it down? Look at the circuit.
Not much.
LED light.
What did it drop to? 4 point what?
4.5.
4.5, let off, goes to 5.2. And if you look at my light, you guys can't see it, but I got it on camera. I can make a little bit of a square wave, but it's actually lighting my test light. So, can I use the incandescent?
No. Oh, yeah.
No.
LED.
Sorry, thank you.
Yeah.
Can I use the LED? No. One last thing, scan data. Let's take a look at it. Cam counts, watch it.
I don't think we have it.
You got it right there. Cam count.
Did it change?
The radio came on too.
Did it change? All right. Did that just pop?
Yeah.
You guys understand because I'm firing this timing injectors and coils when they shouldn't be. Here's the issue though. Is the computer updating this cam count? And the answer is no, not without a crank. So we would have to crank the engine, and Brandon had a good question. Let me get focus back up here. Is this engine going to start if I trigger this. Guys, if I trigger it, I have the potential of backfiring, blowing the muffler apart, backfiring through the intake because I'm mistiming it with my trigger. So I don't really feel comfortable maybe doing that, although it's not my vehicle and it is at the school. It would be kind of fun to see if we can blow the muffler apart.
I'd like to see if it starts.
But you guys understand, we'd have to crank it, provide an RPM signal, and then trigger the cam, and you know, it's not going to be right. I'm wondering if we just look at this a little bit longer, the cam crank counts, if I could get that crank to kick again and show you both that I can trigger this circuit. I just want to try it.
I want the crank. No communication.
I just got a no com. That's
There
weird.
it goes again.
That's what it was doing before. Crank this just to see what happens. I might have actually, hold on.
Get down.
No, I'm not triggering it right now. Let me go back to the scope to show you. Guys, listen. I've done this before
Holy cow.
where I've actually, that's very delayed. That's because of my recording. I've actually caused an engine to start up after triggering a Hall effect like this. It may actually start now.
On a Hall effect?
Yeah.
Okay.
No, I've done it on other sensors too.
Okay.
Go ahead, start that up or crank it. All right, I'm gonna do it. I'm gonna do the trigger. Let's watch the.
Let's do it.
We are gonna do it.
I'd move back.
You're fine.
I'm gonna like hide it.
Go ahead and crank it. Listen, wait. While you're cranking, I want you guys to focus on the crank count. Wait, hold on. Important step. I'm going to just look at cam, crank, and my RPM. Oh, we can look at that one too. Why did I do this? Why did I just do this?
To open up your space. Focus.
Do you see how much faster the data parameters, the frames are updating?
Yeah.
Okay. That's why I did it. Crank it. We got a crank count? Nope. This is what it was doing to us yesterday. Crank it again, see if we lose that. I hope we don't. Go ahead. All right. It's not gonna let us do it. I'm going to
Is that the computer shutting itself off?
I'm not sure why it's doing that. Guys, listen. This doesn't change our call. It needs a cam sensor. We're just doing something a little wacky here. Go ahead and crank it. Okay.
That was actually pretty good.
That's pretty cool.
We lost
That was
data.
enough. You guys understand why that just gave me an intake backfire? I'm firing the injectors at the wrong time, the coils at the wrong time. Are we comfortable though putting a cam sensor in this? Are we comfortable putting a cam sensor in this and fixing this vehicle? I am too. Go ahead. You have a question.
You said it was firing at the wrong time.
Yes.
Wouldn't it be really no time, I guess, technically?
Yeah, I could be firing that spark plug while the intake valve's open,
Yeah,
which is why it just popped through the intake.
Yeah.
Because I'm not timed with the crank at all. I'm just, I was hoping to show you the data PID update. I'm not able to show that because of it keeps crapping out on me. Crank it again. Let's see if that stays. It'd be nice if that would maintain. Of course, now it does, huh?
You say it seems like it's only cuts out.
Well, could it be because we played with the sensor?
Hang on. I really want to show you guys this data PID change. I realize it's lunchtime and we're at the end of this. We're done. The cam and crank counts. Crank it again. It's not even showing me a crank count anymore.
Oh, we really broke it now.
No, we didn't. I still have a crank signal, don't I? Let's go to the scope. Crank it.
Oh, there we go.
It's delayed. This desktop recording is is messing with my scope right now. Do we still have a crank signal?
Yes.
Yeah, I'm not worried about it. We're done, guys. Needs a cam sensor. And you know, think about this. If just triggering the cam circuit, is that playing back? Hold on a second. Is that live now? Crank that again for me. Okay. It's not my desktop recording that slowed it down. Here's the problem with this scope sometimes. If you hit the pause button and then if I hit the green play instead of the red circle, look what it does. I'm in playback mode now. We were looking at playback mode. So that's why it was delayed. Go ahead and crank it again. We're not delayed anymore, are we? Okay. The ScannerDanner PID didn't change like we hoped. Did we hear things clicking? Injectors firing, coils firing, backfiring when I triggered the cam sensor signal. So how's the harness, how's the wiring, how's the computer? Are we feeling 100% confident it needs a cam sensor? We're gonna stop here, get a cam sensor for the thing. The next shot, you're gonna hear this thing run. Sound good? Okay, go to lunch. All right, so we got the old cam sensor out. We're going to put the new one in. That's what it looks like, just a single bolt. And we are absolutely loving these lights that we just got. We got this under hood light, which is pretty sweet. It hooks on the outside of the hood, right? Spring loaded on the ends. Let me show you the one we're using underneath. It's the same light that I was using in, what video did I do? My back pressure video for the Ford Ranger. It is made by Baco, and what's nice about it is it's got magnets all over it, and they're really strong. I could barely pull that off of that sway bar. Makes them real nice. It's got one on the side as well, and made for very nice work for getting to this cam sensor without having to hold the light. So a little special thanks to Baco. Okay, as promised, we have a new cam sensor installed. This is our fix for this vehicle. We're hoping that it's a fix. This is the first time that we've started it. I'm completely lying. We started it already on the last clip, but everybody was talking, and so we're reshooting this again. No big deal. It is a fix. I want you guys to see it. Go ahead and start it up. What we saw the first time around, I was on a 1 second scale. Too much time there. Lower the time base. Freeze that picture, go ahead and shut it off. We can zoom out on that. I'll let you guys see a little bit more of what the cam crank signals look like on this. And green trace is the cam, yellow trace is the crank, and there's, you know, a bunch of different signals and coordinations in there. That's just all about finding which cylinder's which really fast. And obviously with me clicking that green trace with my test light, I was not coordinating these signals properly, and that's why it was, you know, popping and banging and doing some goofy stuff. I guess the last thing that I could show you would be with the scan tool. If I go back to the scanner and we look at that data display, which was our cam and crank sync signals. And hopefully we won't lose communication. I think you guys can see that when we were losing communication while we were cranking, it had nothing to do with our problem on this Jeep at all. Sounds like your Jeep, Ricky, with the communication issues you were having. We are plugged into the data link connector, right? Oh, I didn't switch, put the K13 back in. What we were doing off camera is we were looking at readiness monitors and talking about that, and we had a different chip in there. So a good lesson on having the wrong key is you'll get a no com. So K13. And what we want to look at would be the cam count, crank count, RPMs right below. Go ahead and start it. Shut that off, turn the key back on. What I'd like to try is a clear flood crank. If you can jump in this, turn the key on first, put the pedal to the floor. Now real important, before you start this, it may start. If it does, don't let it rev up, just let your foot off the pedal. I'm hoping to get a no start and just crank it, because that would be a better example of what it should look like with good cam and crank signals for a no start. So we're trying to duplicate that. Let's try a clear flood crank first. So that didn't work, so what I'm going to do now is just disconnect one of my relays, hoping for my fuel pump relay, which is this guy right here. Now this is going to start, run, and stall, so go ahead and start it and let it do that until we run the fuel out of it. Go ahead. Leave it run if it will. Crank it. Okay, good. Alright, so here's what we have now, just so we find some data PIDs that are useful for future, is take a look at these guys. Let me reset the min-max here first. I have to go back and then back in. I want you to look at these graphs for the cam, for the crank, and then let's take a look at RPM, see if we actually get an RPM signal. And go ahead and crank that, let's watch them. Keep cranking it, keep cranking it, keep cranking it, keep cranking, keep. All right, that's good. So you guys can see, as a guide,
That was starting to go up.
cam and crank, and it looks like the crank count, it holds that crank count. Whatever it saw last is what it has in there. Curious to see if that would reset with the key off. Turn the key off, and let's wait till this disappears for, this will come up with a no comm in a second. Turn the key back on, and let's see if it reset that crank count. It did, back to 0. So exiting out and going back in, it didn't do it. That was like held in the computer. Go ahead and crank that again, let's watch it. Give me like a 15-second crank. That's good. Battery's dying. I think that's useful information. If you were doing a no start on one of these and you wanted to know what the cam and crank count should be doing, guys, what you just saw is what they should be doing. Notice we also had an RPM signal. We'll be talking about this stuff further in the term. We get into ignition systems and computer controlled cam and crank signals, what we're looking for as far as direction and no start diagnosis, all of this good information. So thank you guys again for your help. I think that one was really fun.